Hello and welcome to Studying with Chris, where I try my best to explain topics to help both you and me understand concepts. Today we'll be going over factoring polynomials. So, what are polynomials? Well, polynomials are basically any set of terms that have variables, exponents, and constants. So, in most cases, for polynomials, you'll see what are known as binomial, trinomial, and monomial terms. So that's basically saying, say, uh, x squared. This is a monomial, which means it's just one term. Let's say x plus 2. This is known as a binomial. And x squared plus 3 minus x. This is known as a trinomial. These are most of the ones you'll see um, at this level of math, but higher on you might see more terms. But for now, this is generally what you'll be saying, monomials, binomials, and trinomials. Now, for all cases of polynomial expressions, the exponents can only be of whole number values. So for variables in particular, exponents can only be whole numbers. Now, whole numbers just basically means that you can have exponents and you include 0, but you only have counting numbers or natural numbers. So for example, 0, 1, 2, 3, so and so. Most of the time for factoring polynomials or just polynomials in um, grade 11 level, you'd mostly only see up to exponents of 2. All right. So let's get on to how to factor polynomials. All right. So for factoring polynomials, there's almost a surefire strategy that is known as the product sum method. Now, what does this look like? So say you have x squared plus 5x plus 6. Now, if you want to factor this down as it is, it'd be pretty difficult to know unless you know some tricks. So the product sum method looks like this. So first we take the coefficient of the first term, usually it's the one with the degree of 2 in trinomials, and you multiply it by your constant, so this term. Now in this case, our coefficient is not 0, it's 1. So we do 1 times 6, and that gives us to 6. So this is our product. Now, for our product, we need to find factors of this product such that when added together, they equal the middle term. So we'd have to find factors that equal to the middle term. Now in this case, let's see what we get. So we have 6. 6 can be broken down to either 2 times 3 or 1 times 6. Now 2 plus 3 is equal to 5, so I'll say 2 and 3 work. However, 1 plus 6 is equal to 7, so they don't work. So we're going to use 2 plus 3. All right. Now for this in particular, we basically break down the middle term into 2 and 3. So we can say that x squared plus 2x plus 3x plus 6 is equal to the same value of this. Now the reason we do this is because we want to factor these terms out, so we split up the middle term so that we can basically take out values and simplify them. Now that we have an equation like this, we can start factoring out these terms individually. So we have x squared plus 2x. What is a value that they both share? In this case, it's x. So if we take x out of the first term, so x squared divided by x is x, so we take out an x, and 2x divided by x is 2. So what we're left with is x and x plus 2 because we've taken out an x from both of these terms. Now we can't just take out 2 because this we'd also have to take out a 2 from the x squared, so we can only take out shared values. So in this case, we have x taken out of x plus 2. Now over here, we have 3x plus 6. What's a term that we can take out of both of these? In this case, it would be 3, since both of these are factors of 3. So we can say that x times x plus 2 is plus 3 times, if we divide by 3 here, it'd be x. If we divide by 3 here, it'd be 2, x plus 2. So we can say that x times x plus 2 plus x times x plus 2 is equal to our original equation. Now, let's try to factor out this entire thing now. What do we have? So we can see that both of these have x plus 2, so we can factor out the x plus 2, and what we're left with is x plus 3. Now in this case, we can say that the factors in terms of binomials are x plus 2 and x plus 3, since we have a binomial here that we took out of x plus 2, and we're left with x plus 3, which means we can write this all as x plus 2 times x plus 3. Now, if you just want proof to see that this is in fact real, let's try expanding it. Ready? So we have x times x, so this is x squared. We can do x times 3, so this is plus 3x. We can do 2 times x, which is plus 2x. And we can do 2 times 3, which is plus 6. We have two like terms here of 3x plus 2x, so we can rewrite this as x squared plus 5x plus 6, which, as you can see, is equal to our original expression. Now, let's try a different problem just to have some practice. Okay, let's try the same thing with x squared minus 2x minus 15. Right? So let's do the same thing. So we have 1 times negative 15 in this case. So we have minus 15 as our product. Now, what are the factors of minus 15? We have negative 3 and 5. We also have negative 5 and 3. And we have 1 and negative 15. And negative 15 and 1. Now in this case, since our middle term is negative 2, I'm guessing it's probably one of these. So let's see, negative 3 plus 5, that's equal to positive 2, so that doesn't look right. But negative 5 plus 3 is equal to negative 2, so that looks about right. So I'm going to say that these are my middle terms. Therefore, I can rewrite this equation to say that x squared minus 5x plus 3x minus 15 is the same as this equation here. Now let's start factoring this down. So x squared minus 5x, what are our common factors? In this case, it would be x. So we have x times x minus 5 since we take out an x from both. Now for 3x minus 15, what could be our factors? It would be 3 in this case. So we could take out 3 from both of these. So we can say this is equal to plus 3 times x. And since we take out 3 from here, we have x minus 5. Now let's start to factor these down. So we have x minus 5 in both of these. So if we take these out, we're left with x plus 3. Now since we also have a factor here and here, we could say that x squared minus 2x minus 15 is the same as saying x minus 5 times x plus 3. Now if you want to see how to expand it, well, we just do x times x, sorry. So we say x squared, x times plus 3, so we have plus 3x, negative 5 times x, minus 5x, negative 5 times positive 3, we have negative 15, which can be rewritten as x squared minus 2x minus 15. Here. Right. We'll do one just to let you try it on your own, and then we'll walk through it as well. So give this a shot. If you'd like to pause the video, go ahead. Otherwise, I'll start walking through it. So we have a coefficient of 1 times 12. So we can say that our product is 12. And let's split our product into its factors. So we can say that there is 1 times 12. Say that there's 2 times 6. And we can say that there's 3 times 4. Be aware that since this is a positive, all of these factors can also be both negative. So we can also say negative 3 times negative 4. However, in this case, our middle term is positive, so we don't really need to worry about negatives right now. But if your middle term was negative, you might need to worry about that. Okay, so I can see that it's 7, and right away I can see that 3 plus 4 is equal to 7, so I'm going to choose these as my factors. And over here, I'm going to rewrite it to x squared plus 3x plus 4x plus 12. Right? And then we'll factor this down. So x and x, we can take that out. So we have x plus 3. We have 2 factors of 4. So we can say that this is equivalent to saying 4x plus 3. Now x plus 3 is in both of our terms. So we can take those out and we're left with x plus 4. So we can write the whole thing as x plus 3 times x plus 4. Now I'll expand it really quickly. So x, that's x squared, x times 4 plus 4x, x times 3 plus 3x, 3 times 4 plus 12, x squared plus 7x plus 12. Awesome. Now, obviously, this is something that takes practice. You might get it right away, you might not. However, doing it more definitely does help. Once you've reached a certain point where you can do this quickly, there are tricks that make it a lot easier. So just to refresh, our previous answer was x plus 3, x plus 4. There are ways that you can almost skip to this answer. So if I say that 12 can be, since this is our product, 12 can be factored down into 3 and 4. Right away, as you can see, plus 3 plus 4 plus 3 plus 4. So right away, since I know these are my factors, I can say x plus 3, x plus 4. That's the same thing with negatives. So if we say switch this to, let's go over here. Let's say if we switch this to x squared minus 7x plus 12. 1 times 12, our product has to be 12. However, now I know it can be negative 4 and negative 3. So then right away I know my answer is probably x minus 4, x minus 3. Now, this is just a faster trick for um, trinomials, especially, or it technically it really only works this way if your coefficient is 1. So this trick only works if it's 1. However, if your coefficient is any other number, you'd have to kind of try factoring it down using product sum. This is going to be one of the polynomials that you can't factor right away using our trick. This is one that most of the time you'd have to use product sum method unless you know any other method that's faster. But in this case, I'll be using product sum. So as you can see, coefficient of this times our constant, so 2 times 3. So our product is 6. Now we need to find something that is equal to 5. So our products of 6 are 2 and 3, and right away I can see that equals to 5, so I'm just going to stop there. If you do need to do 1, 6, 2, 3, that's perfectly fine, but in this case, I'll use 2 and 3. So it's pretty much the same process. So 2x squared plus 2x plus 3x plus 3. Now here we can see 2x is a common factor since we have 2x squared and 2x. So if I take these out, I'll have 2x x plus 1 because 2x divided by 2x is 1 and 2x squared divided by 2x is x. And over here I have 3x plus 3. I'm going to divide it by 3. So then I'll have x plus 1 since 3x divided by 3 is x and 3 divided by 3 is 1. And looky here, we can divide it by x plus 1. So we'll have 2x plus 3. And altogether we can write this as 2x plus 3 x plus 1. Now this just came to mind, but it doesn't matter which order you put these in. These are interchangeable. As you might get your factors in different order, so you might have um, x here and 1 here, and you might have 2x plus 3 as your factored form. That's perfectly fine. Both will get the job done. You just need to know that you can do it 2 ways, and you need to understand that both will give you the same answer in the end. All right, now that's all for this type of form. We're going to try it with a different kind of polynomial. Now, let's do x squared plus 4x plus 4. Now, we're going to do product sum, but we'll find something out very quickly. So 1 times 4, that's 4. Now 4 can be switched into 2, 2, and 1 and 4, obviously. But we can see right away we have 2 plus 2, so this is 4, so this works awesome. So we can say this is x squared plus 2x plus 2x plus 4. Now we can reduce this, so we can factor out x. So we have x plus 2. We can factor out 2 here. So this is x plus 2 as well. And we'll be left with x plus 2 times x plus 2. Now, since these are both the same term, we can say this is just x plus 2 squared. Now, what we just did is known as a perfect square trinomial. Now, a perfect square, just like any other perfect squares of 4, 9, 100, be written just as a if square rooted, it can be written just as, not 4, but this can be written as 2, root 9 can be written as 3, 100 can be written as 10, and 4 can be written as 2 squared, 9 can be written as 3 squared, and 100 can be written as 10 squared. So these are perfect squares. So what's a perfect square trinomial? Well, perfect square trinomials follow a certain format. This format is something that will be really helpful for factoring polynomials quickly. So this is the written format, it's a squared plus 2ab plus b squared is equal to a plus b squared. Now, what does this mean? This is basically saying that if our first term and our last term are perfect squares, and the middle term is 2 times the sum of their square roots, so, well, it's written just as is, so it's 2 times a, not a squared, 2 times a, and times b, then this whole thing is known as a perfect square trinomial, and you can simply write it out as a plus b squared. Now, let's look at our above expression as an example. So we have x squared plus 4x plus 4. So we see that x squared is a perfect square, so this can be written as x times x, and we can say that 4 is also a perfect square since it can be written as 2 times 2, and we know that 4x is 2ab since it's 2 times, well, 2 times x, since this is our a and b. And then we can do 2 times x, which is equal to 4x. So this satisfies our requirement for a perfect square trinomial. Now this is just one of the many examples. However, seeing this, and if it fits the format right away, we can just say, well, we know that the square root of this is 2 and square root of this is x. We can just simply write this as x plus 2 squared. Now let's try this with different examples now, just to remember it, since this is very important skill. So let's say we have x squared plus 2x plus 1. Now, obviously, since we're under the context of perfect square trinomials, you'll probably guess right away this is a perfect square trinomial. But as you can see, our x squared is in fact a perfect square, and 1 is a perfect square since 1 times 1 is still equal to 1. Now, if we see the square root, so square root of x, square root of 1 times 2, this is just simply equal to 2x, so this satisfies the requirement. Now, if we were to factor this down quickly, we could say that this is square root of x, or sorry, square root of x squared plus square root of 1, which is equal to 1. So we can say that this is just x plus 1 squared. And in fact, the answer is this. Now, there's also a second type of perfect square trinomials that follows just a slightly different type of form. So it's basically the same thing, except now we're saying a squared minus 2ab plus b squared is equal to a minus b squared. So this is just a different format. However, a and b are still both perfect squares, or a squared plus b and b squared are perfect squares. So what would a problem like this look like? And are we sure it's a perfect square trinomial? Well, let's see. Um, let's take a look at, say, um, x squared plus 6x plus, sorry, I'm going to change this, minus 6x plus 9. So let's write this. Let's do product sum. So 1 times 9, we're going to find this is a perfect square trinomial. So, or sorry, it's a perfect square, but we also have a negative as our middle term. So I'm going to say its factors are -3 and -3, since we know that two negatives create a positive, and that's why we have a positive 9. Now we're going to write this as x squared minus 3x minus 3x plus 9, which we can then factor out the x here. So we have x minus 3. We're going to factor out the -3 here. So we're going to have, sorry, Actually, yeah, that works too. We're gonna say minus 3, and we're gonna have x, and since we divide by negative 3, we're gonna have x minus 3 here as well. Now we divide by negative 3 on both, so we'll have x minus 3 remaining, which means we can rewrite the whole thing as x minus 3 times x minus 3, or x minus 3 squared. Now, as you can see, this follows this pattern where the first term was a perfect square, the last term was a perfect square, and since this middle term is a negative, we can simply write it as x minus 3 squared, or in this case, a minus b squared. Now, just to remember, this is almost always a certain format. So the addition here is not something that's interchangeable. It always has to be positive. Now, why is that the case? Well, as you can see here, if we have x minus 3 at x minus 3, obviously we'll do x squared, x times minus 3, x times minus 3. But when we get to the constants, we have two negatives. Now, these two negatives will always create a positive, since a negative times a negative will always equal to a positive. And it's the same thing with a positive, where a positive times a positive will always equal to a positive as well. So that's why in both of these cases, our constants are added and never subtracted. However, our middle terms can be added or subtracted depending on if the second term within our binomial is plus or minus. So these are known as perfect square trinomials, and while you can technically find the factors for them using product sum, it's just so much faster to use the format, because then you save time and you can solve your equations quicker. All right, now give these questions a shot. So for the top, try to find the factors and reduce it to binomials. And for the second one, just try expanding it. The second one will lead us to our next equation, so just give it a shot. All right, now, if you'd like to pause the video or skip to the solutions, go for it. I'm going to start walking through in case you want to see how it's done. So right away, I see that 9x squared is in fact a perfect square, since I can see that it comes from 3x times 3x, and I can see that the second term goes into 2 times 2. Now, since they're both perfect squares, I just need to see if the middle term satisfies the idea of 2ab, a squared plus 2ab plus b squared. Now, 3x times 2 turns into 6x, such that if we times it by 2 because of 2ab, we get 12x. So in fact, it does satisfy this requirement. So while I could use product sum to simplify it, I think it's way easier just to use the perfect square trinomial format. So I can just say that this is simply 3x, and since it's a plus here, we can say that it's plus 2 squared, and that is it. This is a lot simpler, and if you got it, that's awesome. Now let's expand this. Now we're just going to expand it normally, but we'll find something out really quickly. So 3x times 3x, we'll say that's 9x. Now 3x times negative 4, we can say that's minus 12x. Now we're over here, 3x times positive 4 is plus 12x, and 4 times negative 4 is minus 16. Now we can see here, this is x squared, that's my bad. We can see here that's negative 12x plus 12x. So these actually cancel out because you're subtracting 12x and you're adding 12x. So these cancel out. And what we're left with is 9x squared minus 16. Now, as you can see, when we expanded this, we were left with, we used a plus and a minus, but we used the same terms. So we had 3x and a 4, we had 3x and a 4, but we only plused 1, we had minus 1. So this is known as a difference of squares. Now, difference of squares is another way to speed up your factoring process so you don't spend half of your test taking time on trying to factor stuff. So, what is a difference of squares? The difference of squares follow this format where a squared subtracted by b squared is equal to a plus b times by a minus b. Now these are interchangeable since they're, or not interchangeable, sorry, but it doesn't matter the order. This can also be written as a minus b times a plus b. Just so long as a is a perfect square and b is a perfect square and they're subtracted. So let's try a different example. Say we have, let's see, 4x squared minus, well, let's just say 4, right? So this can simply be factored down since we know that 4x is a perfect square of 2x times 2x, and we know that 4 is a perfect square of 2 times 2. So that just means we can write this as 2x plus 2, 2x minus 2. However, there's one big thing that we missed while doing this. So most of the times when you're asked to simplify something or turn it into its most factored down form, you have to do something known as reducing or finding the common factors. So right now, this is not the simplest form. The reason is because we have a 2, 2, a 2, and a 2. So 2 times x plus 2 is equivalent, sorry, I'll just write it out, 2x plus 2 is equivalent to saying 2 times x plus 1 because this 2 will distribute to 2x and the 1. So in this case, right before we do anything, we can do something known as factoring it. And I know this is factoring it, but this is just factoring it before we deal with it. So as we can see, we have a 4 as the coefficient and a 4 as our constant, which means we can factor out of 4 of this whole thing. So we can say this becomes x squared minus 1. Now, even though we factored out this 4, this is still a difference of squares, since this can be written as x times x, this can be written as 1 times 1. So this will still be written as x plus 1 times x minus 1, except now we've just factored the 4 out, okay? So this is what difference of squares looks like. So why is this important? This is probably a question we should have led with, since being able to factor polynomials is an incredibly important skill going into STEM. So I think, from my experience, I think this is most important for a multitude of reasons, especially with the equations that we deal with are trinomials, since trinomials or difference of square equations. So let's say this. This is known as a quadratic equation. Now this basically just means that it has a degree of 2. So the exponent is 2. Now it's not just because this has an exponent of 2, but it's because the highest exponent is 2. Since this exponent has 1, but we say that this equation has a degree of 2. Now, quadratic equations are used for many things. The most notably, if you want a real-life example, is known as projectile motion, where if you have an object and it's thrown at an angle, it creates this curve. Now, interestingly enough, if you graph this equation, where if you substitute x for its values and you plot it out, this equation also forms an arc. So in many times when physicists use a an equation to solve for how far something's going to land, how high it's going to reach, they use what's known as a quadratic equation. Now, this quadratic equation can help them figure out things like these. Now, what's something that's going to be built on from knowing how to factor is knowing how to find zeros. Now, you don't need to know this for now. I'll explain it in future videos. But basically, it's saying if x squared plus 3x plus 4, I don't even really know if this is factorable, so let's go to one that we do know. Let's say, let's go to the one at the beginning, so x squared plus 5x plus 6. If we now say, if this is equal to 0, then what values of x will make this equal to 0? Now, um, I'm just going to skip to the end where I know 1 times 6, so that's 2 times 3, so I'll say this x plus 2 times x plus 3. Now, since we know this is equal to 0, something that you'll have to deal with in the future is saying if x plus 2 is equal to x plus 2 times something is equal to 0, then if x is equal to negative 2, such that negative 2 plus 2 is 0, and whatever this value is doesn't matter, because 0 times anything is 0. So we can say that x equals to negative 2, and it's the same thing here. If x was equal to negative 3, then this would be 0, and 0 times whatever here doesn't matter. It would still be 0. So we can say that x is equal to negative 2 and negative 3, such that if you replace x with either of these values, you'll end up with 0. So this is just something that you'd need to use in the future if you want to go into STEM or math or physics. So this is just an interesting skill to use, and learning how to factor quickly definitely helps with this instead of using product sum. So that's really all from me today. Thank you for listening. If you have any questions, feel free to send me a message. But otherwise, thank you for studying with me.